Okay, today we are starting with the paper 5054, paper 1, variant 2, October, November 2023. It is MCQ's question paper in which 40 questions are there, and you have 1 hour total time for this paper over there. And let's start this question number 1 over there. Here he is saying over here that the diagram shows the level of the liquid in a miring cylinder. The scale is marked in centimeter cube over there, and he is asking for us that what is the volume of the liquid. If I count from here 20 to 30, total 10 over there. So 21, 22, 23, 24. So it is 24 cm cube for the liquid over there. And it will be the right option for MCQ's number 1 will be B option will be right over there. If I move on the next one over there, he is saying that the diagram shows the distance time graph of a car. The car is traveling in a straight road up a hill. Which quantity of car is constant and greater than zero over there? If we say that the acceleration is uh, rate from here distance time graph, I will say that the acceleration is increasing because from the 0 point it is going to somewhere value of the y-axis of the distance it is traveling over there. So acceleration from 0 to get some speed over there, so it is not constant. In case of displacement, it is also not a vector, because it is displacement is a vector quantity, and in distance it can be in any direction over there. And gravitational potential energy is not being specified by this graph over there, but the kinetic energy, that this is the constant speed and is greater than zero, because constant speed, even though that it is that can be in the form of decelerating over there, that the velocity is decreasing or increasing and can be taking negative. And then if I use my formula 1 by 2 mv square over there, then I know even though that there is a positive value or the negative value of the speed over there, kinetic energy will stay always greater than zero. So option D will be fine for it. After that, here he is saying a distance time graph and a speed time graph shows the motion of an object. How are the speed and acceleration of the object determined from these graphs? If we take the gradient, because he is saying gradient will give for distance time graph to me the speed over there. If I want to highlight over here, let's suppose you are getting here it on along the y-axis you have distance, along the x-axis you have the time, and this is the graph, and you get the gradient of this line, then you will say you will get the speed over there. So area under graph or distance time graph, because I need the speed over there first. So that is the gradient of distance time graph. That can be C, that can be D. And on the other hand, he is saying how to calculate the acceleration. I know that this is speed along y-axis and time along x-axis. Then I will say here that it should be also the gradient of the velocity time graph to get the final velocity minus initial velocity over there to get the acceleration over there. So I will say here gradient of speed time graph will be given. So option D will be perfect for this one. For question number 4, he is saying a student finds the mass of a rock is 65 gram. She pours 30 cm cube of water into miring cylinder to get the volume over there, and she places the rock in the water so that the water covers the rock completely. The water level rises to 55 cm cube. So he is saying to calculate the density over there. So I know that density rho is equal to mass over volume. So mass is 65 gram. No need to change because you need in gram again. So 65 divided by it will be taken as 25, because 50 minus 30, 55 minus 30 you will get 25 because this is the volume of that rock. And 25 2 times we can say 2.6 will be fine for it. So option D is perfect for this question over there. Okay, a small submarine of mass 1000 kg sinks in water with a constant speed of 2 meter per second. Means acceleration fa is nothing there. So because this is the constant speed, no acceleration along this, what is the resultant force exerted on the submarine as it sinks? So there is no resultant net force because the speed is constant, accelerating force is zero. So weight will equal to its exactly the drag force over there. So I will say here the resultant force is not available because weight and upthrust are both cancelling out and it is going downward with the constant speed, and there is net force zero over there. No need to go for any other option for the calculation or like that because speed is constant, so resultant force is zero over there. A student drops from the rest a light ball in air. Okay, light ball in air, and the ball experiences some of the resistance as it falls. What happens to the velocity and to the acceleration of the ball during the first few seconds? The main highlight of this question is first few seconds after release, what is happening with it. So I will say here that velocity decrease. In the start, body is at rest, so velocity should increase in the start over there. So decrease is both options I'm ignoring. I'm taking C and D over there. Then he is saying what is happening with the acceleration. Acceleration will in the start acceleration will decrease uh, because it is going to get some constant velocity over there. So acceleration will not be like to increase in this form. It will be like in this form over there, in the form of wave. If I am going to draw the speed time graph over there. So it should not be in this form. It should be like this form. So which I will say it is going to decrease over there. So I'm saying here it is the right option for this question over there. Always try to understand what the statement is telling you. That will be easy one for the solution of the MCQs over there. Okay, the stopping distance of a car traveling at a certain speed is measured in four different situations. Okay, on a dry road with new tires, on a dry road with old worn tires, on wet road with new tires, on wet road with old new tires. Okay, the result W, X, Y, and Z are given 12, 16. This is the stopping distance. This is not the thinking distance over there. This is when you apply the brakes and you want to stop the car. W, X, Y, and Z are being taken all four cases over there. Which two results are possible? Which two results are possible measurements on the dry road with old worn tires? Dry road and old worn tires. So we will say here it will be approximately equal, and old worn tires. So it will be approximately equal. Then we will say it is X, it is Y. That is having approximately equal values, and only 1 meter distance is going to change over there. So I will say here it is B. There is no thinking distance involved. There is no force of friction is going to play a role with the old worn tires, and they are approximately getting the equal distance in only one case because he is not discussing us with the other cases to be taken into account over there. For question number 8, he is saying over here that a spring has a length of 9 centimeter. A spring has a length of 9 centimeter when loaded with 200 grams. Okay. Um, if I say 200 grams here and 2 centimeter is the extension. So the original length of the spring is 7 centimeter, and after this 7 centimeter original length, there is the extension of 2 centimeter over there. If this is the extension which is produced over there, then I will say here that what he is asking for next, then spring is shown. The mass is replaced with 100 gram over there. Okay, now it means at 100 gram the extension is 1 centimeter. So it means I should add with this 7 only 1 over there to get 8 centimeter, which is other option B over there. I think so this is clear now. We should move to the next one. Here he is saying the International Space Station orbits the Earth. Which arrow shows the direction of the force on International Space Station when it is at point X? So it is always directed towards the center of Earth over there. So always whenever you in your this type of paper of MCQs, whenever you look that this is for circular motion question over there, no need to worry or no need to think too much over there. Always take the option which is directed towards the center, which will be the right option for it. Because there is involvement of centripetal force and centrifugal force, and centripetal force is always directed towards center over there, so it is responsible for direction of force. And there is centrifugal force because action and reaction according to Newton's third law of motion is also involved over there. After that, he is saying over here, which expression is equal to impulse? Impulse is basically rate of change of momentum, like force is equal to mv minus mu over t over there. Then we can say it is change in momentum. If I take, then force multiplied time is equal to mv minus mu over there. This can be named as impulse, this can be named as impulse over there. Impulse is basically, for example, Ronaldo is playing football, the force which he's exerting for his muscles of legs over there, and the time for which his foot is in contact with the football, if I take the product both of them, then I will say it is the impulse over there. From here, change in momentum divided by time, no. Change in momentum can be from this option over there. Force multiplied distance moved, that is work. And for the last one, force divided by area, that is pressure. That is not an impulse. So this is fun way how to calculate the change in momentum or impulse over there. A box with mass 4 kg is pulled from rest along a horizontal floor by a constant force. A constant frictional force is 1 Newton acts on the box. When box has traveled 1 meter, its velocity is 1.5 meter per second. The kinetic energy of the box is equal to the work done on the box. What is the force F? So 1.5 and 4 mv. I have to need the calculate for this one in the form of force over there. So he is saying he is moving with the velocity 1.5 meter per second. So 1 by 2 mv square. From here, if I get 1.5, 1.5 was my speed. I am taking its square over there. Mass is 4 kg, and 1 by 2 is still there. So it is 2, and 2 multiply 2.25, it is 4.50 joules is the in a kinetic energy over there. So this was the kinetic energy, and here he said that the current constant frictional force of 1 Newton acts on it. When I take the work from here, then it is 1 multiplied by 1 meter distance is being traveled, so it is 1 joule also. So I will say total is going to happen 1 joule should be added, so it will be 5.5 joules in the form of kinetic energy. And if I want to calculate the force, force is equal to work over distance. I'm taking here over distance, so I will say here that it is 5.5 divided by distance was, that was 1 meter again. So it is 5.5 Newton for this question over there. Here he is saying over here that the diagram shows a curved track. A ball is released from the position at which point the gravitational potential energy of the stored ball is maximum. If I draw a tangent over here to show the circular path over here, then the maximum height is for A and D is still small over there. So A is the point where gravitational potential energy according to the formula mgh is maximum over there. Okay. How does an oil fired power station differ from a nuclear power station? Gases emitted by hard fuel are emitted into atmosphere. It can be because it's a oil field is going to burn and produce carbon dioxide and some other toxic gases over there. Steam is produced in a boiler using hard fuel over there. Steam is produced. Steam can be produced by both of them. Hot steam is used to run the turbine. Yeah, both can be used over there. He is saying to me to calculate the differ, not the similarities. Turbines are used to drive the like so. A is the perfect that oil-filled, oil-fired power station will release the toxic gases into the atmosphere. An electric motor is used to lift a load at a constant speed over there. Okay. The gravitational potential energy stored in the load increases, and moving load has stored kinetic energy, which expression is used to calculate the efficiency. So, gravitational potential energy is being gained over there. So, I will say here that this is as an energy which is gained in the form of gravitational potential energy per second over there, and that will be power supplied. So, efficiency is output over input multiplied by output power over input power should be there. So gravitational potential energy gained per second, kinetic energy gained per second. So both are gained. No, this is not the input in case of kinetic energy over there. So gain in potential energy per second and power supply. So this is fine over there. Output over input multiplied by 100 over there can also be taken for the percentage efficiency for calculation. Power supplied, that is input. Power supplied, that is input. Other two options are not going to be suiting over there. A battery delivers 3000 joule energy to a small 2-watt electric motor before the battery stops working. So for this one, I have to need to use the formula of power is equal to work over time. From that, I will have to take power is equal to work over time. I want to calculate the time over there. Then it will be work over power. Then how much work is? Work is 3000. Okay. Divided by 2, that is 1500, but it is 1500 seconds. He is asking me in minutes. So 1500 divided by 60, 60, 150, 0 is cancelled with 0, 6, 2 times 12, then this is 30, 25 minutes should be there. So option D is perfect for this answer over there. Then he is saying a man finds it difficult to hammer a wooden post on the ground. How could he make the post to go in more easily? A man finds it difficult to hammer a wooden post onto the into the ground. Okay, he want to hammer it, the wooden post into the ground over there. How he could make it more easily? Make the bottom of the post pointed, yeah, so that it can penetrate into the ground over there easily. Make the top of post pointed, no need. Use a longer post, use a wider post. So option A is perfect for it. It should be pointed, or it should be narrow from the face so that it can be inserted and you can get the output which you require over there. Okay, here he is saying which diagram shows the names of the changes of state corresponding to the direction. So solid to liquid is melting, not freezing. Solid to liquid melting, melting, and solid to liquid melting. Okay. Liquid to gas should be evaporating. Sorry. Solid to liquid, not be freezing. So option D will be perfect, I think so. Solid to melting, melting to evaporating, evaporating, condensing, and freezing. So these are the processes in which we can say when solid is converted into liquid, it is melting, liquid to gas, it is evaporating, gas to liquid is condensation, liquid to solid is freezing. In mostly chemistry states of matter chapter, we also study the same thing. Okay, here he is saying over here a sealed cylinder containing gas is left in direct sunlight. Eventually, the cylinder explodes. Okay. How is this explained in terms of the behavior of gas particles? Each particle gets bigger and they collide with particle can never be increasing in its size over there. Each particle gets bigger and now the particles gain kinetic energy and hits the cylinder harder and more often. Yeah, it's fine. And the particles lose kinetic energy when they hit the cylinder now because the energy is conserved according to law of conservation of energy and law of conservation of momentum over there. So C is the perfect. Gas particles gain kinetic energy and hit the cylinder harder and more often over there. After that, here he is saying over there that a gas is trapped inside the cylinder by a moving piston. The length of the gas column is 20 centimeter. Okay, it is 20 centimeter in original. And the pressure inside is P. So I can use the relation over there. P1 V1 is equal to P2 V2 over there. And the piston is pulled out a distance of 30 centimeter. Now it is 50 centimeter in total. So the length of the gas column is now 50 centimeter. The temperature of the gas remains constant. What is the new pressure over there? So I will say here that 20 centimeter is the volume. So 20 into P is equal to uh, P2 is going to 50. What should be the P2 over there? So P2 is equal to 20 over 50 P. So 0, 0. So 0.40 because 2 is inside and point decimal is making 20 over there 0.4. So it is 0.4 P over there. After that, he is saying over here plot X and plot Y are both in cool room. Plot X contains hot water. Okay. Hot water below its boiling point. Plot pot Y is identical to pot X. Okay, but contains water that is kept boiling by a hot plate underneath it. Okay, hot plate is below it and it is getting the continuously formation of water vapors and it is starting to be heating up. What happens to the average kinetic energy of the particles in a liquid water in the pot X and average kinetic energy of the particles in liquid pot Y? So if I look towards this question, that is uh, kinetic energy of the liquid particles in X will decrease because high kinetic energy molecules will leave the surface and causes evaporation, which causes the cooling, and remaining other kinetic energy is going to decrease over there. Kinetic energy of the liquid particles in Y, they will when they are leaving in the form of vapors, then they are having high kinetic energy, but still energy is provided by the hot plate. So there is no cooling or decrease in kinetic energy over there. So it is managed because of the heat provided. So it will be the right option that in case of X, we can say kinetic energy of the liquid in X will decrease because high kinetic energy molecules are leaving and causing evaporation cooling. And in case of Y, the same thing is happening, but the heat is provided by the hot plate and overall kinetic energy is not decreasing over there. Solid metals are good thermal. We know this, that solid metals are good thermal conductors. And how? Because mostly the kitchen utensils are made up of metals for heating purposes over there. How closely packed are their particles and do the metals contain free electrons? And from these options, if we look towards this, packing of particles will be close together in metals, in solid metals over there, and contains free electrons. So option B will be perfect. Close together, no. Why? Metals have the free electrons. Far apart, they are not gases. Cotton wool is a good thermal insulator. It contains many threads of cotton which are tangled together to make a material which can easily be pulled apart or compressed. The diagram shows the structure of the cotton wool. Okay, it is shown. Why is cotton wool a good thermal insulator? Because it has the free air spaces between its surfaces over there. So for this one, I will say here that each thread is very thin, no need. It has a large surface area because it makes many threads. It has the low density because air is trapped. It traps air and prevents the convection. All right, it traps the air, and because there are spaces between the cotton wool threads, so it traps the air and prevents the convection over there. A metal kettle is heated on a grid above a red hot glowing coal. Okay, red hot glowing coal. There is a grid, there is a kettle, and there's a water in it. What are the main thermal energy transferred through the bottom of the kettle and within the water? Then we can say here that when the grid is getting heat up and the base of the kettle is going to heat up, then we can say energy is transferred due to conduction through kettle conduction, and within the water it will be convection because that is liquid. So conduction when the metal through the metal is because conduction we know is the mode of transfer of heat in which energy is transferred due to the vibratory motion of the solid particles which are tightly packed and near to each other, and energy is transferred. In case of convection within the water, because high kinetic energy molecules will move upward and there will be a convection current and are getting towards the hot water over there. Okay, the diagram shows the waveforms. Okay, the diagram shows two waveforms. All right. And which arrow shows the wavelength of the longitudinal waves over there? This is not wavelength. C and D both are not for longitudinal waves over there. And B is for amplitude over there. So A is perfect because from one compression to second compression completely, compression to compression, there is a wavelength. The distance between two consecutive compression or rarefactions is called, I can say, wavelength, or the distance between two consecutive crusts or troughs. So these are the troughs, and crusts are not made for here. Troughs are not made over here. If I take in more prolonged, in case of transverse waves, then I can say that is the wavelength over there. Hmm. For question number 25, a bell on a wall outside a classroom rings. A student is standing at point X. Over student is here. Door is closed. Door open little bit. Okay. Bell is here, and he is saying the door of the classroom is closed, and the student in the room X hears the bell rings. The door is opened, and the sound heard by the student from the bell is louder. What causes for the student? If you look at the student over there, which is present when the door is closed, bell is on opposite side, and when the door is closed, he listens sound fine. But when the door is closed, he opened, he listened a louder sound over there. So, which causes the sound reaching the student to be louder? That can be the diffraction. All right, that can be diffraction. So that we can say bending of waves across the sharp edges over there. When there is no obstacle in the pathway of the sound, it is coming clearly towards the student to hear that. So that is called diffraction. When there is, even though there is a wall between it, is listening the louder sound. That will be the diffraction. Remaining dispersion, no. Reflection, no. Refraction, no. Okay, this is the image, girl, boy, okay. A boy stands beside a girl in front of a large vertical plane mirror. They are equal distance from the mirror. As shown, the boy sees the image of the girl. Okay, this is the boy which sees the image of the girl. At which position he will, where is the girl image over there? Boy is watching from here. Then I can say over here, that girl image will come in this form. For example, this is the mirror, this is the girl. Okay, it will be exactly on opposite side of the mirror, and boy is watching through here, and he can't watch her there over there, because the boy will watch with his eyes at position A over there, because girl's image will be formed exactly behind on the same distance of the mirror over there, will be taken into account. Okay. Light traveling in air is incident on a water surface. The refractive index of water is 1.3 refractive index. Okay. And the angle of refraction of water is 40 degree. What is the angle of incidence? Just use Snell's law over there. That is named as n is refractive index over here, which I have written n over there. N is equal to sine I over sine R. This is angle of refraction, this is angle of incidence. By using the refractive index formula, we can simplify this. And if I apply my refractive index formula, then I get it in the form of 57 degree. You can also check is it correct or not, just by putting the values over there. Okay, here he is saying the diagram shows a ray of light passing through a triangular glass back. Which angle of the critical angle of light is in the glass? What is the critical angle? So, if I look on this figure very clearly, I will say here that this is the normal. This is the normal again. A and C are not giving me critical angle because it is entering from one air medium, for example, to this glass medium, and it is refraction. It is not showing me the angle of refraction of 90 degree. This is not 90 degree. And if I look at this angle of D, if this is the angle of incidence, and after coming out, it is making angle of refraction of 90 degree over here, then I can say position D is the critical angle. Such angle of incidence who is called critical angle, whose angle of refraction is equal to 90 degree. So option D is perfect for this answer over there. Okay, object is lying. Object is here, image is here. It means you are placing it between F and 2F as you are getting over there. But he is saying over here by the calculation, what is the linear magnification? So if I take 1.25 like that, 1.25, 2.25, 3.25. So it is going to three times. Like if this is one, if I mark it here, wait a second. If one, two, three. Wait a second. I have to take the exact one. No, I'm removing it. Wait a second. I'm taking the exact value over there. This is one complete block. 1, 2.5. Okay. 1 and 2. Then again, I'm taking 1.2. So it is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, and 7. Then again, yeah, it's three times. And if I am not given with the graphs over there, then always remember height of image will be divided by height of object to get the magnification over there. Ultraviolet radiations is a component of electromagnetic spectrum which as the application uses the ultraviolet radiation. Bluetooth technology, penetration scanning, sterilizing water, and thermal imaging over there. So sterilizing water is fine. For ultrasound over there, I will say sterilizing water can be used for ultrasound over there. It is just like an application, nothing more than that. A student rubs his hands and rubs different rods held in his hand. Which rod gains a large electrostatic charge? Okay. A polythene rod rubbed with steel magnet. Now, a polythene rod rubbed with woolen duster. Both are in the same state. Iron, no need. Both should be the non-conductor or insulator type objects. You can say, they should not be. They should be insulator. Both should be insulator. It should not be taken in the form of steel and polythene, iron and steel, iron and woolen duster. No need. Always take both insulator objects to be rubbed over there. Two permanent magnets are there, are placed side by different arrangements over there. South north, okay, south south repulsion, north north repulsion, north south attraction. In this arrangement, magnets repel each other. So this is going to show repulsion. This is going to show repulsion over there because same poles repel each other. So 2 and 3. So option C is perfect for it. Which graph shows the current changes when the voltage across the resistor at a constant resistance is varied. It means temperature. What he's saying that the how the current changes when the voltage across the resistor of constant resistance. Okay, resistance is constant. All right. I was a little bit feeling like maybe resistance is changing over there. So this is the definition of Ohm's law. Graph will be straight line over there. No need to worry about the other graphs how they are being formed over there. Okay. Two identical resistors are connected first in series and then in parallel. The two resistors in series are connected to a power supply and the current IS. Current is IS. When they are connected in series, the parallel combination is connected to the same power supply and the current supplied is IP. What is the ratio of IP to IS to IP over there? So I will say here that the power supply is still there. For example, two resistors are in series. Then I will say here one resistor is this, one resistor is this, and they are in series having resistance R, which is in total is 2R. And when they are connected in parallel, when they are uh, connected in parallel, we know this is one resistor and this is one resistor. They are connected in parallel over there. Then the resistance will be half over there, R by 2. R by 2 means half of the resistance over there. If I want to go for the current and for voltage for both of them according to Ohm's law formula, IS is equal to Vs over I is equal to V over R. I'm taking for the first one is 2R when it is connected in series. When it is connecting in parallel, I again say over there that IP is equal to power supply is the same over there. Then it is R by 2 V over R. So I can say here that it is going to take R IS over IP. I need that. So I will have to go here to show that VS is cancelled with VS. 2R IS is there. So it is in the denominator. Wait a second. I want to make it more clear to take it. Okay. So I'm saying here, take the ratio of both of them, Vs over 2R over Vs over R by 2. So I can say here, R is cancelled with R, 2 is multiplied by 2, which is, I think so, 4. Vs is cancelled with Vs. So it is 1 by 4, which is equal to 0.25. So it will be the right answer. Thank you so much for this question. Okay. The output of an AC generator is connected to a lamp. The coil of a generator is rotated at a constant rate, which makes the lamp flash twice every second. The coil is then rotated to at a half rate of rotation. What happens to the maximum brightness of the lamp and lamp flash every second over there? Okay. So we will have to go towards the brightness and number of flashes every second over there. Then we can say brightness will decrease and because there is an output of AC generator connected to a lamp over there and making the lamp twice every second. So every second it is going for twice. It means frequency should be taken every second for that one. So it will decrease and it will give me the number of flashes every second will be 1 because flash is on then off, on then off, on then off. So positive half cycle and negative half cycle for AC generator is available for it. Which device uses the magnetic effect over there of electric current? Compass, magnetic compass, fuse, no need. Loudspeaker, it can use magnifying glass. Okay, it is more perfect. It is using the magnetic effect of the electric current to produce the larger sound over there. Okay, here he is saying a wire is placed at right angles to a uniform magnetic field. Okay, this is the direction of current, magnetic field. This is the direction of current. And he is saying over here, there is a current in a wire that experiences a four beams of alpha particles, beta particles, and neutrons are fired into a magnetic field in the same direction as the conventional current in the wire is passing. All right, he is taking the same case for alpha, beta, and gamma rays over there. Which beam experiences a force that is initially in the same direction as the force experienced by the current over there? So if I look at here, because it is from left to right for going over there, and magnetic field is in upward direction. So alpha particle will experience a force, it's correct. Beta particles will not affected and neutrons will not be affected. So I will go with the option B over there. Here he has also explained the beam experience force in same direction because beta is going to having negative charge, that is not a conventional current flowing, that is electronic current flowing. So I didn't take the beta over there. Here he is saying that the diagram shows the trace produced on the screen of oscilloscope due to alternating voltage of input. The time base of the oscilloscope is 4 millisecond per centimeter. 4, 8, 12, 16 millisecond. Okay. How does it look? The time base is 2 millisecond. So there should not be any change into the amplitude over there. There should be only decrease in, we can say, phenomenon over there. So it is 2 millisecond, 2 and 2, 4, then 4, then so option C is perfect for it. The half-life of a radioactive isotope is 2.5 minutes. Okay. 2.5 minutes. The isotope is the only radioactive isotope in the sample T0 to 7.5. 25 three times. Okay. Decreased by 70 microgram. 70 microgram. What is the mass of the isotope when T is equal to 0? T is equal to 0. T is equal to 0. 7.5 minutes. The half-life of radioactive substance is given. What is he saying over here? The half-life of radioactive is 2.5 minutes. The isotope is the only radioactive in the sample. Between time 0 to 7.5, the mass of the isotope in the sample decreased by 70 microgram. 70 microgram. What is the mass of the isotope is there when T is equal to 0? What is he asking over here? The mass of this isotope. The half-life of a radioactive isotope is 2.5 minutes. The isotope is the only radioactive isotope in radioactive sample. Between T0 to T7.5, the mass of the isotope in the sample decreased by 70 microgram. What is the mass of the isotope at T is equal to 0? So it should be 70 to 80 over there. Yeah. That should be 80 microgram taken over there. When observed on the Earth, the redshift of the light from the galaxy X is smaller than the redshift of the light from galaxy Y. Which galaxy is closer to the Earth and which galaxy is receding over there? Okay, this is X, this is Y. So closer to Earth will be X and faster recession will be Y. So option B is perfect for it. You can read the question again. And thank you so much for today's paper. This was our 5054 O-level paper 1 variant to October, November MCQ sections over there. Thank you so much for today.